PostGIS adds first-class spatial types to Postgres. In the next few minutes, you will learn exactly how geometry and geography differ under the hood and how to spot a spatial bug in a pull request. PostGIS gives you two spatial types: a system of coordinate reference identifiers called SRIDs, constructor functions to build shapes, and a GIST index that makes spatial queries fast. Both types serialize to well-known binary on disk, but the computation model is entirely different. Geometry treats the world as flat. Geography curves with the Earth, which matters the moment your coordinates span hundreds of kilometers. The GIST index wraps every geometry in its bounding box and organizes those boxes into an R-tree. A spatial query first eliminates subtrees, whose bounding boxes cannot possibly match, then checks the surviving rows with the real geometry. Saint_makepoint gives you a raw geometry with no coordinate reference system. You attach one with Saint_setsRID or pass it directly to Saint_geom from text. Casting to geography then switches the computation model to the spheroid. Declaring the column as geography with SRID 4326 encodes the coordinate system in the schema. The GIST index is what allows Saint_d within to prune the R-tree instead of scanning every row. Distance is in meters because the type is geography, not geometry. The vary clause filters to a 5-kilometer radius. The equirectangular formula multiplies degrees by 111,320 meters per degree, correcting longitude by the cosine of the latitude, so the closest location appears first. The classic PR mistake is declaring the column as geometry while passing geography arguments to Saint_d within and forgetting the GIST index entirely. The query runs but returns wrong distances and touches every row in the table. 3 things to flag in a review. Confirm geometry versus geography is the right choice. Check that a GIST index exists on the spatial column, and verify that SRIDs and types are consistent across every spatial function call.